Apparently we need more grades.
Apparently.
This is not going to be happy. I wouldn't stop it.
I'm not. Actually, I stopped it at the end of the packet so I can send it to Denise. And if I could just put it back together.
Oh, we're starting this. We're learning about fluids.
You can see on the board.
They don't
Okay,
know
now from
that.
chemistry,
This
years
is going to
ago,
be the first time I'm going to use my notebook.
that
America.
there are 3 states of matter. Well, there's actually 4, but 3, in our experience. You have the solid state, the liquid state, the gaseous state, and the plasma state.
Oh, God.
The plasma is well beyond our normal experience. So solid, liquids, and gases. Now, of those 3 states, 2 are considered fluids. Your gases and your liquids are both fluids because their shape is the shape of the container in which they are contained. Now, the difference between a gas and a liquid is that a liquid has a surface in that container where a gas will not. But they both fit the container. So if you have a round container, the gas will fill up the round container. If you have a square container, the gas will fill up the square container. Same thing with your liquids. Now the difference between the liquid and the gas is the liquid has a surface, but if you had a gas, the gas would just fill up the whole shape, would have no surface. But they are both fluids. And because they are both fluids, everything we say within the next week or so will apply to either liquids or gases. Generally, the application is to liquids because it's a little easier to apply them there. But you can also get fluid questions with gases as well. And we'll take examples of both. These fluids behave 2 different ways. You have one kind of behavior if there is no motion, which is a static situation. And generally, this division of fluids is what's called hydrostatics. Hydro coming from the Latin for water, and static just stationary. And using water as kind of a generic fluid. If you have movement, then you have fluid dynamics. And fluids behave very differently when they are stationary than they do when they're in motion. So when you are evaluating your problems on the AP exam, the AP exam has increased the size of their fluid section, like 2% over the last few years, at the expense of other sections. In other words, they've taken parts out of thermodynamics, they've taken parts out of modern physics to bump up the fluid section because they feel it is a significant topic to talk about. So you will see fluid problems on the exam. In fact, on the free response part of the exam, there's been a fluid problem probably 3 out of the last 5 years. So first thing you want to do is evaluate, are the fluids moving or are they standing still? Because if they're standing still, you go into one mode of solution. If they're moving, you go into another mode. Now the one thing that fluids exert is pressure. Whether they are liquids or whether they're gases. And your pressure is force over area. And the force of static fluids is just their weight per unit area. So if you have a container of water and you want to find out what the pressure is at the bottom, you would find the weight of the water and divide it by the area over which that weight extends. So literally, what's the weight pushing down on this surface area? Now, generally, what we do for this, okay, is the normal way to measure fluids is not by absolute weight, okay, because it's not like a solid where you can just throw it on a balance, okay? Generally, fluids are measured in terms of their density, which is mass per unit volume. Because again, your fluids have to be contained in something, there's going to be a volume there. Now, if I take my density, which is m over area times height, okay? Area times height is volume. Area is length times width times height. There's my volume. Okay? To convert density into weight, I have to multiply by g. So I got m times area times height times g. Okay? Which I then divide by area, which then gives me density times g times height is my pressure.
Oh, wow. And that's why I'm putting these online.
Now, density is always designated by the Greek letter rho. Okay, unless you've got linear density, and then your textbook gives it the mu. But on the AP exam, it's designated by the Greek letter rho. On your AP formula sheet, there's a whole section for fluid mechanics. They define the variables, and the variable rho, which is the last one in the column, is density. Now, this is mass density. Okay? There are some problems that you will see, and generally the AP doesn't use this, but you never know what they're going to do year to year. They might give you a weight density. In other words, instead of kilograms per cubic meter, they would give you newtons per cubic meter. That's a weight density. And in that case, you don't need the G anymore, because the G is already included in that. In your weight density, this would be newtons per, or this would be weight per unit volume, which is already mg. So I wouldn't have to multiply by g. So if you're given a weight density, don't bother with the g. Otherwise, rho times g times h gives you the pressure. Now, of this particular relationship, okay, this will work anytime, anywhere, for any fluid. The pressure depends on the height. That's the key. So when they ask you, well, what is the pressure at the bottom of a container where your water is 10 meters high? Well, your pressure is 10 meters times G times the density of water, which is 1,000 kilograms per cubic meter. And that's what your pressure is. Your pressure will come out in units of newtons per square meter, which is your pressure unit. Suppose I have a container that's 100 meters high. What's my pressure? 1,000 times G times 100. So the height is the main and single determinant of your pressure. Okay? So keep in mind, pressure is related to height. As the height changes, the pressure changes. And this is for static fluids, fluids that are not in motion.